66 million years ago, on an otherwise ordinary Tuesday morning, a rock the size of a city fell out of the sky. Traveling at roughly 70,000 kilometers per hour, the Chicxulub asteroid, approximately 10 to 15 kilometers wide, struck what is now the Yucatan Peninsula of Mexico with the force of several billion Hiroshima-level nuclear bombs detonating simultaneously. In the first second of impact, the rock vaporized. In the first minute, the shockwave leveled everything within 1,000 kilometers. In the first hour, the ejecta from the impact was already re-entering the atmosphere around the world, superheating the sky, igniting global wildfires. In the first year, a cloud of dust and debris blocked the sun so thoroughly that photosynthesis effectively stopped across the entire planet. Within the following decades, 3/4 of all species on Earth were gone, including almost every dinosaur that had ever walked, swum, or flown across this planet. Almost, because some survived, the small, feathered, warm-blooded ones, the ones we now call birds, they made it through. And 66 million years later, they are still here, perched in your garden, singing in your trees, completely unaware that they are the last surviving branch of the most successful animal dynasty in the history of life on Earth. But what if the asteroid had missed? Not by much, a few degrees of trajectory, a slightly different angle of approach, the kind of margin that feels impossibly small when you consider what was at stake. What if the rock that ended one world had simply continued on through the darkness of space, leaving this one untouched? What if the dinosaurs never went extinct? This video is the answer to that question, not as a theory, not as a debate, as a journey. We are going to travel forward through 66 million years of alternate history, watching this world evolve without the extinction event, and we are going to arrive, finally, in the present. Today, this world as it exists right now, if the asteroid had missed. To understand what happens next, we need to understand what the world looked like on the day before impact, because most people have the wrong picture in their heads. They imagine the late Cretaceous as a simple world of giant monsters in a jungle, Tyrannosaurus stomping around, velociraptors hunting in packs, enormous brontosaurus-style creatures browsing in swamps. The reality was far more sophisticated. 66 million years ago, the dinosaurs had already been the dominant life form on this planet for 165 million years. Let that number sit for a moment. 165 million years. For context, the entire history of our species, from the first anatomically modern humans to today, is less than 300,000 years. We have existed for less than 0.2% of the time that dinosaurs ruled this planet. And in those 165 million years, they had evolved into something extraordinary. The Cretaceous world was not a swamp. It was a complex, layered, biologically rich ecosystem that would have looked in many places surprisingly familiar. There were forests. There were flowering plants. This period saw the first explosion of angiosperms, the flowering plants that now dominate our world. There were rivers and deltas and shallow seas. There were insects and small mammals and birds, early primitive birds sharing the sky with their pterosaur relatives. And the dinosaurs themselves were not the lumbering, cold-blooded reptiles of old science textbooks. The latest research tells a different story. Many were warm-blooded, many were fast, many were covered in feathers, many were highly social, traveling in herds, raising their young, communicating in ways we are only beginning to understand. Some had brains that were, for their body size, surprisingly large. The most intellectually promising of them all was a creature called Troodon. Troodon was small, roughly human-sized. It walked upright on two legs. It had forward-facing eyes, the kind that give depth perception, the kind that suggest a predator that needed to think rather than just react. It had relatively large hands with grasping fingers, and it had, for a dinosaur of its era, an unusually large brain, a brain that paleontologist Larry Whitmer described as giving Troodon the cunning of a fox. In our timeline, Troodon went extinct with everything else 66 million years ago. In this one, it did not. The asteroid misses, the sky does not catch fire, the sun keeps shining, the food chain remains intact. And the Cretaceous world exhales. For the first few 100,000 years, relatively little changes. The dinosaurs continue doing what they have been doing for 165 million years, living, eating, competing, reproducing, dying, evolving. The great herbivores browse the forests. The great predators hunt them. The small, feathered mammals like Troodon dart through the undergrowth, eating insects and small mammals and the eggs of larger species. The small mammals, those tiny, furry, nocturnal creatures that had been hiding in the shadows of the dinosaurs for over 100 million years, continue to hide. They remain small, they remain nocturnal, they remain marginal. Because the ecological niches that in our timeline they exploded into after the extinction event, those niches are still occupied. Fully, aggressively, comprehensively occupied by dinosaurs. This is the first great divergence between our timeline and this one. In our world, the extinction of the dinosaurs was like someone clearing the board in the middle of a game. All those ecological roles, large herbivore, apex predator, mid-level omnivore, suddenly vacant, suddenly available. And the mammals, small and furry and warm-blooded and adaptable, rushed in to fill them. Horses, elephants, whales, lions, us. All of us are the products of that sudden, catastrophic vacancy. In this world, the board is never cleared. The pieces are never removed. The mammals stay in their corners, small and surviving but not expanding, not diversifying, not evolving toward anything that would eventually produce a primate and then a human. Humanity, as we know it, will not exist in this timeline. But something else will. Something that, in its own way, is just as extraordinary. 10 million years after the asteroid misses, the climate begins to change. The Cretaceous was one of the warmest periods in Earth's history. There was no polar ice. Sea levels were dramatically higher than today. Vast shallow seas covered much of what is now dry land. And for the largest dinosaurs, the long-necked sauropods, the enormous ornithopods, the massive ceratopsians, this warm, food-rich world was a paradise. But Earth's climate does not stay still. The continents keep moving, ocean currents shift, carbon dioxide levels in the atmosphere change, and over the following millions of years, the planet begins to cool, slowly at first, then more significantly. This is the first great test for our surviving dinosaurs. In our timeline, some scientists had theorized that even without the asteroid, the dinosaurs might have struggled with this cooling trend, that they were already in decline when the rock hit. But a landmark 2025 study put that theory to rest. The fossil record, re-examined with new techniques, showed that dinosaurs were not in decline. They were thriving. Their apparent diversity drop in the late Cretaceous was an artifact of poor fossilization conditions, not actual population decline. So our dinosaurs go into the cooling period at full strength, diverse, adaptable, 165 million years of evolutionary experience behind them. And what evolution does, when the environment changes, is select. It keeps the forms that work in the new conditions, and it discards the ones that do not. The enormous sauropods, those long-necked giants that required vast quantities of warm-weather vegetation, begin to struggle. Over millions of years, the largest forms dwindle. Some go extinct. Their ecological role is taken by smaller, more adaptable herbivores. But the smaller dinosaurs, the nimble ones, the warm-blooded ones, the feathered ones, the social ones, they do something remarkable. They thrive. The cooling climate paradoxically accelerates their evolution. The pressure of changing conditions drives rapid adaptation. New forms emerge, new behaviors develop, and among the small, intelligent Maniraptoran dinosaurs, the descendants of creatures like Troodon, something begins to happen that, in our timeline, happened only once in the entire history of life on Earth. Intelligence begins to build on itself. 20 million years after the asteroid misses, the world looks dramatically different from the Cretaceous. The great giants are mostly gone, replaced by a more moderate diversity of large herbivores and their predators. The forests have changed. The flowering plants that were just beginning to diversify in the Cretaceous have now spread across the planet, creating rich and complex ecosystems that support enormous biodiversity. The seas teem with marine reptiles and fish. The skies are full of birds, the flying descendants of the earliest avian dinosaurs. And on the ground, in the forests and open plains of every continent, a new kind of creature is emerging. Canadian paleontologist Dale Russell was the first scientist to seriously ask what might have happened to Troodon had it survived. In 1982, working with artist Ron Seguin, he built a detailed scientific model of what he called the Dinosaur, a hypothetical evolved descendant of Troodon that had been given another 60 million years to develop. The result was striking: a bipedal creature, upright stance, forward-facing eyes. A large, rounded skull housing a significantly expanded brain, three-fingered hands with opposable grip, roughly human-sized. Russell's Dinosaurid looked disturbingly familiar, because evolution, when it selects for intelligence and tool use and social complexity, tends to arrive at similar solutions regardless of the starting material. The same pressures that shaped our ancestors, the need to cooperate, to communicate, to plan, to remember, to solve novel problems, those same pressures are now acting on the descendants of Troodon. They are not human, they will never be human. Their skeleton is different. Their sensory world is different. Their color vision is extraordinary, extending into the ultraviolet range. Their social structures are different. Their communication, a complex system of vocalizations, body postures, and the rapid color changing of specialized facial crests, is unlike anything in our world. But they are intelligent. Genuinely, increasingly, purposefully intelligent. They make tools, first crude ones, stones used to crack bones, sticks used to probe for insects in bark. Then, over hundreds of thousands of years, more refined ones, shaped stones, composite tools, tools made from materials gathered from different places and combined deliberately. They live in social groups with complex hierarchies and long-term relationships. They communicate in ways that carry abstract information, not just immediate signals about danger or food, but information about the past and the future, about things that are not present, about plans. They are, in every meaningful sense of the word, beginning to think. Here is the thing about intelligence. Once it starts, it does not stop easily. Intelligence is what biologists call a runaway selection trait. The smarter you are, the better you survive. The better you survive, the more offspring you have. The more offspring you have, the more the genes for intelligence spread through the population. And the smarter the next generation is, and the one after that. It is a feedback loop, and once a species gets caught in it, evolution moves fast. For our dinosaurs, let us call them that, borrowing Russell's term, the next 40 million years are a story of accelerating complexity. Not smooth, not linear, not without setbacks and extinctions and ice ages and crises. Evolution never is, but the overall direction is unmistakable. 30 million years after the asteroid misses, they control fire. Not deliberately at first, they learn to use naturally occurring fires to carry embers to maintain flames. But within a million years of that first encounter, they are creating fire intentionally. And fire changes everything. Cooked food releases more calories than raw food, allowing their brains to grow larger without requiring their bodies to spend as much energy on digestion. Fire provides warmth, extending the range of environments they can inhabit. Fire provides light, extending the day, giving more time for social activity, for communication, for the transmission of knowledge between generations. 40 million years after the asteroid misses, they build shelters, not just using existing caves and overhangs, but constructing, first simple frames of branches and large leaves, then more permanent structures, then structures that are clearly architectural, designed, not just assembled. 50 million years after the asteroid misses, something extraordinary happens. They begin to mark things. First on stone, then on prepared surfaces. Not just images, though there are images, rich and complex and beautiful in ways that reflect a visual system more sensitive to color than our own, full of ultraviolet hues that our eyes would not perceive. But writing in the fundamental sense, a system of marks where each mark carries agreed meaning, where marks can be combined to create new meanings, where the accumulated wisdom of a generation can be recorded and transmitted to the next without requiring direct contact. The moment a species develops writing, everything changes, because before writing, every generation starts almost from scratch, carrying only what can be memorized and transmitted orally. After writing, knowledge accumulates. Each generation inherits not just the biological evolution of its ancestors, but the cultural and intellectual evolution. They build on what came before, faster and faster. The dinosaurs have discovered civilization, 60 million years after the asteroid misses, 6 million years ago in our time. The dinosaur civilizations are extraordinary. Let us be specific, because the specifics matter. They have had 60 million years to develop. We have had at most 10,000 years of what we call civilization, the period from the first cities to today. 10,000 years versus 60 million. The gap is not just large, it is almost incomprehensible. So what does a civilization look like that has 60 million years on ours? It is a question that genuinely humbles the imagination, because every technological achievement we are proud of, writing, mathematics, agriculture, architecture, metallurgy, the wheel, steam power, electricity, nuclear energy, computers, space travel, all of these took us, at most, 10,000 years to develop from scratch. What does 60 million years of accumulated development look like? We can make some reasonable guesses based on what we know about how intelligence and civilization develop. They understand their world at a depth we have not yet reached. Their mathematics, developed over millions of years of accumulated refinement, describes the universe with a precision that makes our most advanced physics look like arithmetic. Their medicine, evolved from a completely different biological understanding, working with a completely different biochemistry, can cure diseases and repair injuries that in our world would still be death sentences. Their relationship with energy is different from ours. 60 million years of development means they solved the problems of energy generation and storage that we are still struggling with, not through magic, through the accumulated application of intelligence to the same physical laws that govern our universe. The same laws, the same elements, the same forces, just more time, more minds, more generations of building on what came before. Their cities are real, but they look nothing like ours. A dinosaurid city 60 million years into civilization would be organized around a completely different set of biological imperatives and aesthetic sensibilities. Their color vision extends into ultraviolet, so their architecture is rich with patterns and colors that would be invisible to our eyes. Their social structures are different, more complex, more layered, the result of millions of years of cultural refinement, and their cities reflect those structures. The large, non-intelligent dinosaurs still exist alongside them, or at least their descendants do. 60 million years of coevolution has produced a relationship between the dinosaurids and the other species of their world that is, in some ways, more sophisticated and more balanced than our relationship with the animals of our world. Not necessarily more peaceful, predation is still real, competition for resources is still real, but more understood, more navigated. And the mammals. The small, furry, nocturnal mammals that survived the Cretaceous alongside the dinosaurs, they are still here too. They never had their explosion. They never diversified into horses and elephants and whales and primates. They stayed small, stayed nocturnal, stayed marginal. There are thousands of species of them, filling the small animal niches of this world. But none of them is large. None of them is complex. None of them is on the path to intelligence. That path was taken by the dinosaurids 60 million years ago. And now we arrive. Welcome to a version of today, the same date on the cosmic calendar, the same sun, the same moon, the same continents in roughly the same positions, but everything else different. The air is the same, or close enough to the same that a human being transported here would be able to breathe it without assistance. The planet is still a planet. The sky is still blue. The oceans are still water. Physics still works the same way. But the living world on this planet is unrecognizable. There are no humans, there never were and there never will be. The small, rat-like proto-primate that in our world eventually became us. In this world it is still a small, rat-like creature hiding in undergrowth, not significantly different from its Cretaceous ancestor. We are not here, we never happened. What is here is something so far beyond what we could have become in 60 million more years that comparison almost seems absurd. The dinosaurid civilization, not one civilization, but many, diverse across different continents and environments, as varied as the human civilizations of our world, but with 60 million years more complexity layered upon them, has transformed this planet in ways that are both familiar and completely alien. The cities of the dinosaurid world are structures of extraordinary sophistication, not tall in the way our skyscrapers are tall. That particular architectural impulse is a human one, driven by our specific relationship with gravity, land scarcity, and aesthetics. The dinosaurid cities are organized vertically in a different way. They extend into the ground as much as into the sky, layered deep in ways that reflect a species that evolved partly underground, in burrows and tunnels, before their intelligence took them above ground. The surfaces of their structures are alive with color and pattern in the ultraviolet spectrum, invisible to our eyes, but to the dinosaurids, as vivid and meaningful as the text on the page you are reading now. Their cities communicate. The surfaces of buildings carry information, cultural, navigational, social, encoded in patterns of ultraviolet color that have been refined over millions of years into a visual language of extraordinary richness. The air above their cities is not empty, not because they have flying vehicles. They do, though they look nothing like ours, but because they never stopped being partly aerial creatures. The dinosaurid lineage maintained its connection to the sky. Their cities are designed with aerial pathways and platforms, and the whole three-dimensional sense of space that a species with deep evolutionary roots in avian movement brings to architecture. We cannot fully describe dinosaurid technology, not because it is magical, but because 60 million years of development has taken it so far beyond our conceptual framework that most of what they know, we do not yet have the language to express. Think about it this way. A person from 10,000 years ago, a person from the earliest human civilization, transported to our world today, would not be able to understand most of what they saw, not because they were less intelligent, because the accumulated conceptual framework behind our technology, the thousands of years of mathematics, physics, chemistry, engineering, was not available to them. They would see the results but not understand the causes. Everything would look like magic. Now imagine how a person from our present would appear to a civilization 60 million years more advanced. We would be the person from 10,000 years ago. Everything would look like magic. The honest answer is that we cannot fully imagine their technology. We can say it is real, it obeys the same physical laws our technology obeys. We can say it is vast, the product of 60 million years of accumulated development. And we can say it is theirs, evolved from a completely different set of biological imperatives and aesthetic sensibilities and social structures than the ones that shaped our technological development. It is not our future, it is a different present entirely. Here is one of the most extraordinary aspects of this world. The non-intelligent dinosaurs, the descendants of the Cretaceous herbivores and predators that were not on the path toward dinosaur-style intelligence, are still here. 66 million years of evolution has transformed them dramatically. The Tyrannosaurus of the Cretaceous has descendants, but those descendants look nothing like their ancestor. They have been shaped by 60 million years of continuous evolution, adapting to changing climates and ecosystems, and the increasing presence of the dinosaurid civilization alongside them. Some have become smaller and faster. Some have diversified into ecological niches that did not exist in the Cretaceous. Some have been pushed toward extinction by the spread of dinosaurid civilization. As our civilization has driven species extinct, theirs has too, though their relationship with the non-intelligent species of their world has been modulated by millions of years of cultural development, an understanding that we have not yet achieved. The world is still full of extraordinary life, not our life, not any life we would immediately recognize, but life, rich and complex and astonishing, filling every ecological niche on every continent and in every ocean, the product of 66 million years of uninterrupted evolution. With 60 million years of accumulated technological development, have the dinosaurs left this planet? Almost certainly. We reached space in 60 years of serious technological development. From the first powered flight in 1903 to the moon landing in 1969 was 66 years. From nothing to the moon in 66 years. The dinosaurs have had 60 million years. Where they have gone, what they have found, what the universe looks like to a civilization that has been exploring it for tens of millions of years, that is a question too large for this video. But the answer, almost certainly, is that the solar system of this alternate Earth has been thoroughly explored, that the nearest stars have been visited, that the dinosaurid civilization extends in some form far beyond the single planet. This planet, this Earth, it is their home world, the place where it all began, 66 million years ago, when a rock the size of a city chose a slightly different path through the darkness and left everything intact. We are not in that world. We are in this one, the one where the asteroid did not miss, the one where 3/4 of all species on Earth died in geological instant, the one where the small, furry, marginal mammals rushed into the vacuum and eventually, 66 million years later, produced us. And there is something important in that. We exist because of a catastrophe. Our entire lineage, every primate, every ape, every human who ever lived exists because of the worst day in the history of this planet. The asteroid that killed the dinosaurs was not good. It was not natural justice. It was not the universe clearing the way for something better. It was an accident. A random piece of rock on a random trajectory through an indifferent universe, intersecting with a planet at exactly the wrong moment. And from that accident, eventually, came us. This is both humbling and extraordinary. Humbling because it means our existence is contingent, dependent on a random event, not inevitable, not planned, not the product of any cosmic intention. A few degrees of difference in an asteroid's trajectory, and we never happen. Extraordinary because it means that out of catastrophe, out of mass death, out of the worst moment in this planet's biological history, something managed to crawl forward, something survived, something adapted. Something 66 million years later developed the capacity to look back at the catastrophe that made it possible and understand, partially, imperfectly, but genuinely, what happened. We are the children of an extinction event. That is not a poetic metaphor. That is our literal family history. And if the dinosaurs of our alternate world could somehow look across the timelines and see us, see these small, soft, warm-blooded creatures that never got their chance in the shadow of the great reptiles, and yet somehow are here, 66 million years later, asking questions about the universe, I wonder what they would think. I think they might be impressed. Not by our technology, we would be thousands of years behind anything they knew. Not by our civilization, we would be children to them, but by the sheer improbability of us, by the fact that we emerged from catastrophe, by the fact that we are here at all. There is something worth holding onto in that. The universe did not make us inevitable. We made ourselves. Out of nothing but time and pressure, and the stubborn insistence of life on continuing. Before you go, I want to ask you something. If you could choose, if some cosmic architect offered you the choice before either timeline began, which world would you pick? The world where the asteroid misses, where the dinosaurs survive, where intelligence takes a different form in a different body and has 60 million more years to develop than we have had. A world of extraordinary civilization and technology and achievement that we cannot even fully imagine, but a world with no humans in it, no us. None of the art or music or stories or love or grief or humor or stubborn, messy, complicated, beautiful humanity that fills our world. That world does not exist in this timeline. It never can. Or the world where the asteroid hits, where 3/4 of all life on Earth is destroyed in a single geological moment, where the small mammals, our ancestors, rush into the ruins of the old world and begin 66 million years of evolution that eventually, improbably, produces us. A world of extraordinary human achievement, yes, but also of extraordinary human failure. Of war and poverty and environmental destruction, and all the things we have done to each other and to this planet. A world that is 60 million years behind the dinosaurs in development, but a world that has us in it. The asteroid hit, we exist, here we are. Tell me in the comments, are you glad it did? And if you could send a message to the dinosaur civilization of the alternate timeline, those extraordinary beings 60 million years ahead of anything we have ever achieved, what would you say? Because I think that question tells you something real about what you value, about what you think humanity is actually for. I want to know your answer. Also subscribe so we can meet again.